So one really important thing to know about just inequalities in general, and the difference is that in an equation, when we say x equals 5, there's only one answer. So equations have one answer usually. That's not always true, but usually they just have one answer. Okay, we're just given the answers that are equal to the given equation that we start with. Now, an inequality, so like x being greater than 5, this is an inequality, has a range of answers. Meaning there are lots of numbers that are going to make an inequality true. Now, because of that, because inequalities have multiple answers, there's going to be multiple ways to represent that solution. It's not just saying x is 5 or x is 7. Instead, we're going to have number lines. We're going to also write an inequality statement, like what you see right here, x being greater than 5. And we're going to even introduce a new way to represent inequalities, a way that I would guess that nobody in here has seen yet. Now, before we jump into a few more things about the inequalities, I first want to touch on the symbols. And knowing that we have these symbols down and know what each one represents. So let's just write this underneath the right slide here, where this first symbol, that's your less than. And then when we flip that, that's greater than. And then one thing that we're going to add on to some of these symbols is a line underneath, which changes it from less than to now less than or equal to. And then the reverse, greater than or equal to. Now these you need to memorize if you don't know them already. You should be able to see a symbol and tell me what that name is. And a lot of times, like when you all ask me for help, or one thing I'm going to always have you start with is reading inequalities out loud. A lot of times when you see it and you say it out loud to yourself, you get that greater than or the less than. It's going to help you figure out how to represent the solution on the number line in the right way. So speaking of just reading inequalities, and I'll give you a sec, I can see some of you still writing. But the way that we read inequalities is going to be very specific. Most of the time, we read everything left to right. That's natural for just how we read a book, how we read paragraphs, even how we read math. But with inequalities, that may not always be the case. When reading an inequality, it is really important that you start from the variable. So always read an inequality from the variable. So a good example, and there's a lot of examples on here, but this is x is less than 2, and it even tells you how to say it or how to read it. Again, that's something that we need to practice, and something I'm going to encourage you to do every time we work through an inequality problem. Now, if I read left to right, this says that 2 is greater than x. And so if I tell you to give me a number where 2 is greater than x, I'm not quite sure what that is telling me to describe. Okay, it's not all that clear. But if I read with the x first, x is less than 2, I'm like, oh, these are the exact same inequalities. Okay, x is less than 2. So no matter where the x or the variable shows up with your inequality, when you read it, start with that with that variable first. It makes a huge difference. Okay, so as you continue to ask questions or work through problems, I will ask you, give me the variable or say the variable first, and that should help. Okay. Because our solutions to inequalities are a range of values, we're going to represent them on number lines. And part of our number line is going to have us putting the value in which we get our inequality for. We're going to put a circle on that number line. The circle will either be filled in or open based on which symbols they are. So if we have less than or equal to or greater than or equal to, we fill that inequality in. And the reason for that, if I have x is less than or equal to 5, well, that would mean that 5 is less than or equal to 5. Is that true, that 5 is less than or equal to 5? That's true, right? Because that's true, we include the value of 5 itself. As opposed to if x is less than 5, and if now we say 5 is less than 5, that's not true, right? Without the or equal to part, this is not a true statement, and thus we leave that value at 5 open. Okay, so open circles when it's just less than or greater than, closed circles when it's less than or equal to, or greater than or equal to. The last part is we're going to shade values. If we have a less than symbol, we're going to shade to the left because on a number line, all the numbers to the left of the number we get are smaller than that original number. And then greater than, we're going to shade to the right. Okay. All we're doing today is drawing number lines and writing what some number lines show us. I'm going to always encourage you to read these out loud before you just start putting things on paper. So starting with the variable, this is k is less than 5. You do not need to write it every time. I'm more so just writing it to remind us to start with the variable and to be willing to say it out loud. Be willing to mumble it underneath your breath when you're working through these. So I'm like, okay, what numbers are less than 5? Well, I'm first going to put my circle at 5. I need to decide whether to color it in or leave it open. Because it's just less than, it stays open. And then all the numbers that are less than 5 are numbers to the left. Number 2, that is k is greater than 0. And so again, I use an open circle because we're not including 0. 0 does not make this inequality true. And I shade all values to the right, which are all values that are bigger than 0. Right then, n is greater than or equal to -2. So I'm going to put a closed circle this time because of the or equal to. And then values greater than -2 are all numbers to the right. N is less than or equal to 5. I'm going to put a closed circle at 5. All numbers that are less than 5 are numbers to the left. All right. So the next set of problems has us the number line part already filled out. Your task is going to be to take what that number line is showing and write the given inequality. Okay, so basically what we started with 1 through 4, that represents that number line. Now, since we're in new groups, I'm going to actually have you start by first introduce yourself. And make sure everybody in your group knows your name. So, there we go. Here are the inequalities that the number line is representing. Starting with x being less than or equal to 1 is the inequality for number 5. Number 6 is that x is greater than or equal to -3. He's not here. Thank you. Have a great weekend. Number 7 is showing that x is greater than 6. Number 8 is showing that x is less than -4. Again, read them out loud. If you don't know, think about what numbers are shaded, right? Like, let's use a greater than here. If I'm like, oh, 4 is shaded here, and it is bigger than -3. Thus, x needs to be greater than or equal to -3. So feel free to actually use numbers that have been shaded to help you decide, is it less than or greater than? And then remember the filled in circles tell us that we use the or equal to symbol. Open circles means we just leave it as either greater than or less than. All right, go ahead and flip this over. as the next piece that we're going to add on to our inequalities is by writing them in a notation called interval notation. This is going to be new for every single one of you in here. Okay, or at least that's my guess, is that we haven't seen this before. So it's another way of writing an inequality using that interval notation. There are two types of brackets. We're basically going to be using brackets and parentheses to say the same thing that an inequality is showing. So we're going to use, I call these squared brackets, whenever we have the or equal to, so greater than or equal to or less than or equal to. And then we use regular parentheses if it's just greater than or just less than. So no or equal to, we use regular parenthesis. Or equal to, we use the squared off bracket. Now, we're also going to be using the infinity symbol because when we look at our number lines, how many numbers are less than -1? Infinitely many, right? We could literally spend the whole class period going around one by one where each of you tell me a number that is less than 1. We could go all day. We could go the whole entire week doing that exact same process. We will never stop naming numbers that are less than 1. So because of that, when using interval notation, infinity is going to show up quite often. Okay, so the infinity symbol is a sideways 8, and that's again going to show up with almost every single one you write, definitely every single one you write today. Now, what the interval notation looks like. It looks very similar to if we were writing a point, right? Like an x comma y. So we have brackets, we have a comma in the middle, and what we do is we put the lower number or lower value on the left and the higher value on the right. And what this is saying is all numbers between our lower number and higher number, okay, is how we would read this. And so these are the same number lines that we had just written the inequalities for, where we had said that x is less than or equal to 1, x is greater than or equal to -3, x is greater than 6, and then x is less than -4. So that is the inequality portion. And what I'm going to have us do, and this is also how you're going to do your homework, we're going to write the inequality, but then we're going to say what the interval notation would be. So what we have to ask ourselves is, what is the lowest number or lowest value that this number line is going to? It's going all the way to -infinity. Then the highest number that it gets to is +1. So what this interval notation is saying is all numbers between -infinity and 1. For number 6, again, starting with the lower value, which is -3, going to the largest value, where it just keeps going and going all the way to the right, to +infinity. Now again, notice my brackets here. I have squared brackets on the numbers because of them being or equal to. Those numbers make the inequality true. But the infinities don't have squared brackets. Does anyone have an idea as to why? Another way to think about these brackets, the squared bracket, we use that if we actually get to that value, right? So like on this number line, we actually get to 1. 1 is included. Can we ever get to infinity? Nope. That is not possible, right? If I asked you to name the biggest number you can think of, I can name a number that's bigger. And we could keep going back and forth to where we never actually get to infinity. So you all know, like Toy Story, Buzz Lightyear, what's his saying? Yeah, is he true? Is that a true thing? No! Buzz Lightyear doesn't know what he's talking about. You can't get to infinity and then go beyond it. You can't ever get to infinity. So Buzz Lightyear, he just didn't know much about math. His saying makes sense for what he does, but it's not real. Anyways, I love Buzz Lightyear. I'm just saying his saying isn't very mathematically correct. That's okay. That's not the point of Toy Story. They can do whatever they want. Anyways, let's keep going here. We're almost done. X being greater than 6, our lowest number here is 6. And again, we don't actually get to 6. That's not included on our number line because it has the open circle. So we use a regular parenthesis. And it goes all the way to the right to positive infinity. X is less than negative 4. That's negative infinity is the smallest value. The largest value is negative 4 with a regular parenthesis because we never actually get to that specific value. All right, what I want you all to do, 9, 10, 11, and 12. Write the inequality and then the corresponding interval notation describing that inequality. Give y'all like 2 minutes to work through 9, 10, 11, and 12. So again, I want to see the inequality and the interval notation. And again, the question that I get in this looking 2 years from now or even 3 years from now, even then I get the same types of questions that seems like, how do we know if it's squared or a regular parenthesis? It all depends on that specific value. So this squared bracket is referring to what's happening at 6. At 6, since we actually include that value, because of it being less than or equal to, we use a squared bracket. So the squared bracket is referring to what's going on at 6. The negative infinity, that regular parenthesis, is referring to what happens at negative infinity. And remember, we'll never get to infinity. Okay, we're not like Buzz Lightyear where we get to be there and go beyond. Okay, so we never get there using just a regular parenthesis. Same thing with negative 2 here. That regular parenthesis is saying that we don't ever get to negative 2. We get infinitely close to it, which is a weird idea. But the smallest number that works here is like negative 1.99999999999. We can list 9s forever. Okay, but you never actually get to negative 2. All right. Any questions with inequalities, number lines, or interval notation before we do one last thing here? All right. Last thing are just taking a sentence and writing the inequality that represents that. The first thing that's important for us to identify is what part of this sentence is telling us that it's an inequality and not an equation. For 13, it's the at most. The theater can hold at most 550 people. In order to qualify for free shipping, you must spend at least $75. In order to vote, you must be at least 18 years old. So those are the words telling us that this is an inequality as opposed to an equation. Now, with sentences or word problems, which we're going to do a bunch as we progress through our curriculum, I'm going to always have us define our variable. Okay, so what is the part that is changing here? What's changing for 13 is the number of people. In 14, what's changing is how much we spend. So X is money spent. And then 15, when we're thinking about when we can vote, that's going to be our age. So X is the age. And this is always a great place to start when trying to go from sentence into a math sentence, whether that be an equation or an inequality. So if we can have at most 550 people, that means X, the number of people, needs to be less than or equal to 550. Okay, at most means we can't go beyond 550.
But if we're writing the
Interval notation. That is a great point. Okay, so Hunter's thinking about what happens if we go from this inequality into the interval notation. The negative numbers make sense when we're thinking about how many people can fit in a theater. No, right? We're not going to have negative people in that theater. What does that even mean? Okay, so we would say that we can have 0 to 550. So we have to kind of think about what numbers make sense in terms of the problem. So it wouldn't be negative infinity, it'd be 0. Okay, that's great. Okay, that's an awesome connection to make there. All right, 14, in order to qualify for free shipping, you must spend at least $75. I'm going to have you wait like 2 minutes, Jake. We're almost done. Okay, so that means we need to spend greater than or equal to 75. Now, if we think about this in terms of the problem, the money spent to get us free shipping is 75 to infinity. If only we had infinite number of dollars to spend, that'd be pretty stinking cool. That's not the case, at least not for me. But that'd be awesome. So free shipping, spend infinity dollars, you get free shipping. Anyways, 15 in order to vote, you must be at least 18 years old. So X needs to be greater than or equal to 18. And again, as an inequality, I guess it would still be infinity, even though that's not possible. We can't live to be infinity. What is the oldest somebody's ever lived to? Does anyone know? 116?